Hi, I'm Angel Leonard and welcome to the course JSF Fundamentals. I'm a senior software developer with more than 12 years of experience in Java Standard and Enterprise editions. Speaking about JavaServer Faces, I'm working with this Java Enterprise framework since 2007. In the past few years, I've also written several books. So far, I wrote 2 books about JavaServer Faces and both of them are available at Pact Publishing. One is named JavaServer Faces 2.0 Cookbook and the other one is named Mastering JavaServer Faces 2.2. I'm also sustaining and promoting JavaServer Faces on my personal blog named OmniFaces Fans. Okay, I think this is enough about me. Now let's see what we will cover in this video course. So, there are 2 main goals covered in this course. First, we will talk about expression language and cover the most important aspects of expression language 2.2 and 3.0. We will continue with a comprehensive dissertation about communication in JavaServer Faces. Having these skills in your arsenal will save you from spending time trying to fix malformed and broken expressions, and also debugging communication issues. This is important because these kind of problems are pretty common in JavaServer Faces applications, and they can really delay the application development. We will start with an overview of EL syntax, continue with immediate and deferred evaluation, value and method expressions, and we will finish with EL resolvers. Next we will explore the features brought by EL 3.0, such as lambda expression support. Further, we will talk about JavaServer Faces communication aspects. We will talk about passing and getting different kind of parameters, such as context, request, and view parameters. Also, as part of communication, we will discuss about actions, cookies, and hidden fields. The final part is reserved to communication aspects between JavaServer Faces managed beans. Here, we will talk about injection and communication between beans based on application or session map. So the goal of this video is to provide a bunch of very useful knowledge that should be known by any JavaServer Faces developer. Beside this talk, you can also check out several applications that are proof of concepts described in this course. Among these examples, you have an application that creates a custom EL resolver, another one that passes parameters using flash scope, and another one that shows how to programmatically access managed beans. In order to run the examples, you will need NetBeans 8.1 or higher, JavaServer Faces 2.2, and an application server, such as Glassfish 4.1.1, Payara 4, or Wildfly 10. Okay, I really hope that you are interested in the topics of this video and you are ready and excited to begin. So, I hope to see you soon. Hi and welcome to the section 1 of Core JavaServer Faces course named Introduction to EL. Before having a brief overview of what this course will cover, let's say that Java EL is a powerful mechanism that enables dynamic communication in JSP and JSF based applications, including development frameworks based on JSF such as Prime Faces, Ice Faces, and Rich Faces. In order to communicate with the application logic layer, we place the expressions in the presentation layer. Further, EL provides bidirectional communication, which means that we can expose application logic data to the user, but we also can submit user data to be processed. Generically speaking, EL can be used to accomplish several kinds of tasks, such as populating HTTP requests with user data, extracting and exposing data from HTTP responses, updating HTML DOM, conditionally processing data, and so on. In this section, we will cover 3 topics as follows. We will start with an overview of the main aspects of EL 2.2 and 3.0 syntax, which means that we will talk about EL operators and reserved words that must be known in order to write well-formed expressions. Next, we will discuss about value and method expressions, including immediate and deferred evaluation of EL expressions. The last part of this section is reserved to EL resolvers, and here you will see what is an EL resolver and how to write a custom one. Now we move on to the first video of this section that deals with EL syntax. As we just said, EL supports a handful of operators and reserved words, and each of these are covered in this video. We are also interested in how these operators take precedence when they are used together in the same expression. Depending on their goals, the EL operators can be arithmetic, relational, logical, conditional, or empty. Starting with EL 3.0, we also have the string concatenation, assignment, semicolon, and lambda operators. As you can see, we have 5 arithmetic operators. It is important to keep in mind that these operators work with respect to mathematical operations, as addition, subtraction, and so on. For example, this means that the plus operator cannot be used for string concatenations. Let's check out the below 5 examples. As you can see in the first example, the plus operator will compute the addition of 3 and 5, while in the third example, the same operator will cause an error, since it is used as a concatenation operator, which is a bad practice. So, as long as we respect the mathematical rules, we can implement different calculations, as you can see in the second example. Finally, take a look at examples 4 and 5, which are correctly evaluated even if we are using simple or double quotes around numbers. The relational operators provides us the support for performing different kind of comparisons. The result of a comparison is a Boolean value, and in order to understand how these operators are evaluated, let's have several examples that implies numbers and strings. In the first example, we simply compare two numbers. This is very intuitive and works exactly as expected. Going further, the second example tries to determine if two numbers are equals, and as you can see, EL can distinguish between integers and numbers with decimals. This means that we can perform high precision comparisons using numbers. From the third example, we can easily conclude that EL compares strings in an alphabetical manner, not based on strings' length. The last example reveals that two strings are equals if they contain the exact same characters. Notice that the comparison is case sensitive. Next, let's take a look at the EL logical operators. This kind of operators allows us to write complex comparisons, obtained by chaining multiple comparisons in a logical approach. The Boolean result represents the evaluation of this complex comparison. By combining logical and relational operators, we can obtain pretty complex comparisons. However, keep in mind that using the logical AND operator can be a little tricky. Since JavaServer Faces uses facelets as its view declaration language, and facelets is based on XML, we cannot use the logical AND operator via the ampersand character, because this is a reserved character in XML. As an alternative, you can use the AND symbol or the escape version, as you can see in the second example. The conditional operator, also known as the ternary operator, evaluates B or C depending on the result of the evaluation of A. Let's check out a few examples based on the JSF API. In the first condition, we try to determine if the current request is an AJAX request, while in the second condition, we try to find out if the current request is a passback. Further, in the third example, you can see a nested condition that verifies if the current request is a passback only if the validation didn't fail. So now we can use the ternary conditional and logical operators together in order to write complex conditions. The empty operator is used to determine if the given value is null or empty. It is commonly used for strings and collections, but it is also used to determine if certain objects are null. For example, we can check if a string is empty or if a list has items. If you take a look at the third example, you can see how to determine if the current response contains any kind of messages, such as the error messages. Starting with EL 3.0, we have access to several new features, including the new operators listed in this table. Each of these operators will be discussed in detail in a future video that belongs to section 2. We skip this topic for now and pass further to symbols used to write EL expressions. Besides the ones that you already saw, we also need the following symbols for writing an EL expression. First, we have to demarcate the EL expression via a dollar or hash sign and a pair of braces. As you will see later, there is no difference between using hash, which is preferred, or dollar. Further, we have the dot or square brackets. In EL, the part of the expression before the dot or the square bracket is named base, and it usually indicates where the bin instances should be located. The part after the first dot or square bracket is called a property. This is recursively tracked in smaller parts that represents the bin properties to get from the base. Next, we have the round brackets, which are used to indicate a method expression or to simply change the precedence of operators. Finally, we have the single double quotes, which are used to demarcate strings or literals. Conforming to EL specification, the precedence of operators from highest to lowest and left to right is as you can see on this slide, so please take your time and read the entire list. Also conforming to EL specification, the following list represents the reserved EL keywords. So, pay attention to not use these words to name your variables, functions, properties, and so on. So in this video, we have covered the main aspects of EL syntax. We have discussed about EL operators, such as arithmetic, relational, logical, and so on, continued with symbols used to write EL expressions, and finished with the list of precedence of operators and reserved words. In the next video, we will discuss about value and method expressions, so join me there. Hi and welcome to the value and method expressions video. In the previous video, we looked at EL operators, symbols used to write EL expressions, the precedence of operators, and EL reserved words. In this video, we are going to take a look at value and method expressions from JSF perspective. We start with a quick intro about immediate and deferred evaluations of expressions, and continue with different techniques for writing value and method expressions. So, EL evaluates expressions as immediate or deferred. Immediate evaluation returns the result as soon as the page is first rendered. These kinds of expressions are read-only value expressions, and they can be present only in tags that accept runtime expressions. They are easy to identify after the dollar notation. Usually, they are used for arithmetic and logical operations in GSP pages. Deferred evaluation can return the result at different phases of a page's lifecycle, depending on the technology that is using the expression. JavaServer Faces can evaluate an expression at different phases of the lifecycle, depending on how the expression is being used in the page. This kind of expressions can be value and method expressions, and they are marked by the hash notation. The important thing to keep in mind consists in the fact that in Facelets, which is the JavaServer Faces default view declaration language, the immediate and deferred evaluation act the same. Further, let's talk about value expressions. Well, value expressions are probably used the most, and they refer to objects and their properties and attributes. Such expressions are dynamically used to evaluate results or set bin properties at runtime. Through value expressions, you can easily access Java Beans components, collections, and Java Standard Edition enum types. In addition, EL provides a set of implicit objects that can be used to get attributes from different scopes and parameters values. Next, you will see how EL deals with each of these objects. Value expressions that can read data but cannot write it are known as R-value, while those that can read and write data are known as L-value. Referencing a managed bin is not exactly a useful example, but it is a good point to start using value expressions. Most commonly, your JSF or CDI managed bin stub will look like what is shown in this slide. Now EL can refer to the player's bin like this. Basically, the name is obtained from taking the unqualified class name part of the fully qualified class name and converting the first character to lowercase. If your bin has an explicit name, then you should use that name instead of the one computed by default. Note that when the pointed bin cannot be found in any scope, a null value will be returned. As is commonly known, bins usually contains private fields, which are accessible through getter and setter methods as bin properties, and some public methods that exploits these properties to serve different logical tasks. EL expressions that can access these properties contains the dot or square brackets notation. For example, let's suppose that the player's bin contains a field named player name. EL can access this field through its getter method, so you need to define a getter like this. Now an expression that accesses the player name property can use the dot notation to refer it, as shown in the following line of code. Alternatively, this expression can also use the square brackets notation, as shown in the following line of code. JavaServer Faces evaluates this expression from left to right. First, it searches for player's bin in all available scopes, such as request, session, and application. Then, the bin is instantiated and the getPlayerName getter method is invoked. Notice that in the case of Boolean properties, the getter method will be prefixed with is instead of get. When you are using the brackets notation, you can use simple or double quotes. Just remember to alternate them correctly in cases like the following quotations. For example, you cannot use double quotes inside double quotes or simple quotes inside simple quotes. On the other hand, you can use simple quotes in double quotes and double quotes in simple quotes. Okay, let's go further and discuss about how to reference a bin's nested properties. Usually, bins use nested properties. Such properties can be accessed by EL using the dot and brackets notations multiple times in the same expression. For example, the player's bin may contain common data about tennis players, such as names, titles, finals, and so on. More detailed information, such as birthdays, birthplaces, and so on, can be represented through a different class, such as players details list here. Now the player's bin contains a field of type players details, which means that the birthday property becomes a nested property of player's bin. So you already know how to call the player name property using the dot and brackets notations. Next, you can use the same notations to access the birthday nested property, as shown in the following code. Now the player details class can contain its own nested properties and so on, In such cases, just use the dot and brackets notations to get deeper in the hierarchy of objects until you reach the desired property. In these expressions, JavaServer Faces search for player's bin in all the available scopes and obtain an instance of it. Afterwards, it calls the getPlayerDetails method and the getBirthDate method. Now, EL can access Java enum types using a string literal. For example, let's have an enum type named place that contains two values, left and right. In player's bin, we declare a field of type place named simply play. Further, you can easily access the play field by using its getter as shown in the following line of code. If you want to refer to the place constants, in this case place.left and place.right, use the proper string literal, which in our example can be left or right. For example, you can test if play value is left or right as shown in the following code. Further, let's talk about referencing collections. Well, collection items such as arrays, lists, maps, sets, and so on can be accessed from EL expressions by specifying a literal value that can be converted to an integer, or the brackets notation with an integer and without quotes. For example, let's suppose that the player's bin contains an array named titles that keeps the titles won by a player. Now, you can access the first title from the array by specifying its position in array, which is 0. The needed expression looks like this. You can use the same approach for lists. For example, in the case of list, we can use the get and set methods, as in these expressions. But sometimes you need to iterate over the array instead of accessing a specific item. This can be easily accomplished with the for each GSTL tag, or another approach consists in using the repeat component handler. In the case of collections of type key values such as map, the EL expressions obtain items by key. For example, let's add a map in player's bin that stores some match facts of a player. Now, an EL expression that accesses the item with the key aces can be written like in the following line of code. When the key is not an acceptable variable name, for example double faults, you need to use brackets and quotes as shown in the following code. JavaServer Faces provides several objects related to the current request and environment. EL exposes these objects, known as implicit objects, that can be accessed at runtime in a facelet, servlets, or backing bin. These objects are accessible through value expressions and are managed by the container. In EL, the part of the expression before the dot or the square bracket is named base, and it usually indicates where the bin instances should be located. The part after the first dot or the square bracket is called a property and is recursively cracked in smaller parts, which represents the bin's properties to get from the base. For each expression, EL first checks if the value of the base is one of these implicit objects, and if it is not, then it will check bins in scopes, from request to view, session, and finally to application scope. Okay, enough about value expressions. Now let's talk about method expressions. With EL expressions, we can call arbitrary static and public methods that live on the server side in managed bins. Such expressions are usually present in tags attributes, that is, inside an action or action listener attribute. In addition, this expression must use the deferred evaluation syntax, since a method can be invoked during different phases of the lifecycle. Commonly, methods are invoked to respond with actions to different kinds of events and for navigation tasks. Okay, let's see some examples of calling bin methods using EL. all methods were defined in player's bin. First, let's call a void method without arguments. As you can see, we simply chain in the expression the bin name and the method name, separated by dot notation. A similar expression can be used to invoke a method with return, but without arguments. The returned string can be displayed on the web page or used for other purposes. In other words, in this example, the expression will be evaluated to this string. In this example, we invoke a void method that received one argument of type string. Notice that the string arguments are passed by using quotes. In case of other types, such as numbers, do not use quotes. When the invoked method received more than one argument, you have to separate them by comma. The expression from this example will be evaluated to the string Vamos Rafael Nadal. Finally, let's invoke a method that returns an outcome. First, we need to define the method in the bin to return a view name. In this example, the return string Vamos is the view name of the vamos.xhtml file. Next, extract the view name in the action attribute of any JavaServer Faces command component, such as command button. Now, when the button labeled Vamos is clicked, JSF will resolve the view name Vamos to the vamos.xhtml file. In addition, JSF will look for the vamos.xhtml file in the current folder and will navigate to it. Commonly, these navigation methods are used for conditional navigation between JSF pages. Notice that in all examples we have used parentheses to call a method, even when the method doesn't contain arguments. A special case is represented by the methods that contains an action event argument. These methods should be called without parentheses, except in the case when you override the action event argument, which implies passing and specifying custom arguments. In this video, we have covered main aspects about immediate and deferred evaluation, value expressions, and method expressions. In the next video, we will talk about writing custom EL resolvers. So, see you soon. Hi and welcome to the EL resolvers video. In the previous video, we learned how to write value and method expressions. In this video, we are going to take a look at EL resolvers and how JSF deals with them. We will start with a brief overview of the EL resolver concept, meant to identify the responsibilities of this kind of artifact. Further, we will iterate the main built-in EL resolvers that are heavily exploited by JSF during lifecycle, and end up with a proof of concept of writing a custom EL resolver. In order to dispel the mystery behind EL resolvers, let's start by saying that EL resolvers are actually instances of Javax EL resolver class. After a quick look over the documentation, we can easily notice that there is a bunch of predefined EL resolvers, and that EL resolvers are part of EL context, next to function mapper and variable mapper. Just as a note, the EL context is responsible to provide the context for creating or evaluating an expression. As the name suggests, the main goal of EL resolvers is to resolve expressions, or, with other words, to turn expressions into object references. In order to resolve expressions, the JavaServer Faces EL resolvers access the model, which consists in managed bins, implicit objects, and so on. So let's suppose that EL resolvers must resolve an expression like this. Notice that the EL resolvers will resolve the expression by respecting the Javax EL API, which provides classes for resolving several common types, such as arrays, bins, maps, and lists. Also, notice that this API is not related to JavaServer Faces. So the expression will be evaluated from left to right. First, it searches for the base foo in all available scopes, such as request, session, and application. Then the bin foo is instantiated, and the bus property is resolved by calling the getBus method. Further, the bis property is resolved via getBisGetter, and the result of evaluation is returned. Notice that JavaServer Faces novices tend to believe that EL expressions and EL resolver are useful only if we are using bins, which is not true. These are further aggregated via Javax EL composite EL resolver, but this is a topic that is not discussed here. So each time an expression needs to be resolved, JSF will call the default expression language resolver implementation. Each value expression is evaluated behind the scene by the getValue method. Now the EL implementation comes with a chain of resolvers for different types of expression elements. For each part of an expression, EL will apply the chain until it finds a resolver capable to resolve that part. So a single expression is resolved by a single resolver or after a teamwork of several resolvers. The resolver capable of dealing with that part will pass through to the setPropertyResolved method. This method acts as a flag at EL context level. Further, EL implementation checks after each resolver call the value of this flag via the getPropertyResolved method. When the flag is true, EL implementation will repeat the process for the next part of the expression. So, the chain of responsibility contains a set of EL resolvers, which are applied one by one for each part of an expression until one of the resolvers is capable to resolve that part. For example, the Oracle implementation of JavaServer Faces comes, among others, with the following EL resolvers. First, we have the implicit object EL resolver, which is capable to deal with JSF implicit objects. Remember that implicit objects allows us to use EL expressions in order to expose JSF artifacts such as faces context, session map, and so on. Another one is managed bin EL resolver. As his name suggests, this is responsible to resolve the part of an expression that points to a managed bin. So, in an expression as foo_buzz, this resolver expects to identify the foo as the name of a managed bin. Of course, it doesn't know that, so it has to perform some searches. For example, it can try to find the bin name in request, session, or application scope. Next, we may consider the resource EL resolver. This is responsible to resolve expressions that indicate resources, such as style sheets and JavaScript files. Basically, it will identify the resource and uses the resource handler createResource method to create it and return its request path. Okay, there are more EL resolvers, but I believe you understood the idea. As an exercise, you can also check Faces Resource Bundle EL resolver. So in JSF, most expressions are linked to managed bins, implicit objects, and resources, but you have to know that this is not mandatory. Nevertheless, let's suppose the following scenario. We want to access the EL context object as an implicit object by simply writing EL context instead of faces context.EL context expression. This task can be achieved by writing a custom EL resolver. Basically, we extend the EL resolver class and override its methods to shape our example. So let's do it. Our custom EL resolver is named EL context resolver. Of the available methods, the getValue is the most important method of an EL resolver, so we have to pay more attention to it. This method is responsible to accomplish the following tasks. Identify the part of the expression that it can resolve. Invoke the EL context setPropertyResolved method to signal that it can resolve or not a certain part of the expression. And finally, if it can resolve a part of the expression, then simply do it. So first stop is at line 6. The EL context expression doesn't need a base. So we ensure that the base is null. With other words, we don't accept something like foo.el context. As a quick tip here, keep in mind that null base should always be resolved as a value expression. The el context string acts as a reserved word and is case sensitive. Basically, JSF will apply the chain of available resolvers until it hits the el context resolver. No other resolver will be able to resolve the el context expression. So, notice that the el context variable is matched in a simple manner via the equals method. The third argument passed by JSF in getValue should be exactly the el context string. As a note here, in an expression of type foo.buzz, first the property will be foo, afterwards buzz. For the foo, the el resolver class acts as a variable resolver, while for the buzz, since there is the base foo, the el resolver class acts as a property resolver. Further, let's take a look at line 7. If the base is null and the third argument of getValue is el context, then this resolver is capable to resolve this expression. It must signal this to el context, so the chain of resolvers can be interrupted for this part of the expression, and the next part of the expression, if any, will enter in the chain. For signaling that the el context expression can be resolved by this resolver, we need to invoke the el context setPropertyResolved method and pass to it the boolean argument true. As long as this flag is false, JSF will try to apply the next resolver from chain. Next up is at lines 8 and 9. It is time for the el context resolver to accomplish its main goal, which consists in resolving the el context expression, or, with other words, to turn this expression into an object reference. Practically, at this point, we exploit the JavaServer Faces API to obtain the current el context. Generally speaking, here we place the code necessary to link that part of the expression with an object, such as constant, collection, primitive, object, managed bin, resource, and so on. This code is basically the programmatic approach of accessing that artifact. Final stop is at line 11. In order to understand this line, think that other expressions may pass through this resolver, not just our el context expression. In such cases, the el context resolver will not be able to resolve them, so we have to return null. The getType method identifies the most general acceptable type for our property. The scope of this method is to determine if a call of the setValue method is safe without causing a class cast exception to be thrown. Since we return the current el context, we can say that the general acceptable type in our case is el context. This means that if the setValue method allows us to set a value to this expression, then that value must be of type el context. The setValue method tries to set the value for a given property and base. In case of a writable base property pair, you have to check here the type of the passed values, and if they are okay, then set them. Since we have a read-only variable, there is no need to do that. We just signal that this is a read-only variable via an exception. Normally, before calling setValue, the developer should check if this is a read-only resolver via isReadOnly method that is covered next. So for read-only variables such as el context, you need to throw an exception of type propertyNotWritable exception. The implementation of the setValue method can be accomplished like this. Next, let's talk about the flag method isReadOnly. This method returns true if the resolver is read-only and false otherwise. Notice that this method is directly related to the setValue method, meaning that it signals if it is safe or not to call the setValue method without getting a property not writable exception as a response. The getFeatureDescriptors method returns a set of information about the variables or properties that can be resolved. This is commonly useful to design time tools that allows code completion of expressions. In this case, just for fun, we have set several properties that you can see in the complete application that is delivered with this course. The getCommonPropertyType method returns the most general type that this resolver accepts. We can simply return the string class here. So, our custom resolver is ready, but we have to instruct JSF to use it. By default, JSF will try to resolve the EL context expression via the current chain of resolvers, and is not aware of our EL context resolver. In order to add our resolver in the chain of resolvers, we need to add the EL resolver tag in facesconfig.xml file like in this slide. When JSF will find this config, it will add the EL context resolver next to the existing ones. So, when the EL context expression needs to be resolved, JSF will apply the chain of resolvers, and at some moment, it will find the EL context resolver as the proper resolver for the EL context variable. Next, you can fire a simple test from a JSF page. We can try to obtain the locale by using our custom EL resolver and the classical approach. Both of them should return the same thing. If we glue everything in an application, then we will obtain something like this. Notice the EL context resolver, which is basically our custom EL resolver. Here we can easily identify the methods described earlier in this video, such as getValue and isReadOnly. In order to see how our custom EL resolver works, we can try to obtain the locale via the classical approach or via the custom approach. So, let's run the code. As you can see, both approaches returned the same result, which is exactly what we have expected to see. In this video, we have covered several EL resolvers topics. You just saw what an EL resolver is, what are the default EL resolvers, and how to write a custom EL resolver and attach it in the default chain of resolvers. In the next video, we will talk about the new features brought by Expression Language 3.0. See you there! Hi, and welcome to the Section 2 of Core JavaServer Faces course named EL 3.0. In this section, we will explore the Expression Language 3.0 features from the JSF perspective. Keep in mind that this features works only starting with JavaServer Faces 2.2. In this section, we are going to take a look to the headlines of EL 3.0. While EL 2.2 expressions can be used to dynamically access data stored in Java Beans components and to call arbitrary static and public methods, EL 3.0 comes with more features that boosts EL 2.2 to the next level. So in this section, we will cover three main topics of EL 3.0. We start with an overview of the new operators, the assignment, the string concatenation, and the semicolon operators. In the next videos, we will discuss about two more features of EL 3.0. We begin with one of the headlines of EL 3.0, represented by the powerful lambda expression support. Further, we will pay attention to how to create and manipulate collection objects via EL 3.0 features. Now we move on to the first video of this section that represents a brief overview of working with EL 3.0 operators. Each of these operators can be used to achieve several kinds of tasks, which in the past were resolved using different workarounds. So we start with the assignment operator, continue with the string concatenation, and finish with the semicolon operator. In an expression of type x equal y, The assignment operator equal will assign the value of y to x. In order to avoid an error of the kind property not writable exception, the x value must be an L value. The following two examples shows you how to use this operator in two simple expressions. The assignment operator is right associative. This means that z equal y equal x is the same no matter where we place brackets. For example, an expression of type z equal y equal x plus 4 is evaluated to 7. Now in an expression of type x plus equal y, the string concatenation operator plus equal returns the concatenated string of x and y. Check out our first example and notice that we apply this operator against two numbers, but the result reveals that EL interpreted these numbers as some strings. In the second example, you can see that the concatenation operator can be applied multiple times in the same expression. Of course, since this operator is dedicated to concatenate strings, we can easily provide strings in simple or double quotes, as you can see in the third example. In EL 2.2, we can achieve the same goals as this operator by using the concat function as in the fourth example. Basically, the semicolon operator is like the Java semicolon statement, and it allows us to group a number of expressions together. In an expression of type x semicolon y, x is first evaluated, and its value is discarded. Next, y is evaluated, and its value is returned. For example, we have chained three expressions using semicolon, and the logic will go from left to right like this. First, we assign values to x and y, and after that, we compute the sum of x and y and assign the result to z. So z is equal to 8. In this video, we have covered the three new operators brought by EL 3.0. You saw how to use the assignment, the string concatenation, and the semicolon operators. In the next video, we will go further and we will discuss about lambda expressions. This should be a very interesting topic, so see you there. Hi and welcome to the second video of this section. In the previous video, we looked at EL 3.0 operators. While in this video, we are going to take a look at EL lambda expressions. We start with a quick overview of lambda expressions meant to distinguish between Java and EL such expressions. Further, we will talk about EL lambda expressions immediate and indirect invocation. Continue with passing EL lambda expression as arguments to methods, and finish with nested EL lambda expressions. The lambda expressions sustain functional programming, and they are also called anonymous functions defined and possibly called without being bound to an identifier. A lambda expression is represented by a block of code that you can pass around, so it can be executed later, just once or multiple times. A lambda expression can be splitted in three main parts: parameters, the lambda operator, and the function body. Basically, in Java language, a lambda expression represents a method in an anonymous implementation of a functional interface. In case of EL, a lambda expression is reduced to an anonymous function that can be passed as an argument to a method. An EL lambda expression is a value expression object with parameters. The body of an EL lambda expression is an EL expression. It is important to not confuse Java 8 lambda expressions with EL lambda expressions. But in order to understand the next examples, it is also important to know the fundamentals of Java 8 lambda expressions. So in case that you are not familiar with the Java 8 lambda expressions, you better take a break and dig in some documentations. The Java and EL lambda expressions don't use the same syntax, but they are similar enough to not cause notable discomfort when we need to switch between them. So EL supports several kinds of lambda expressions. The simplest and easy to write type of lambda expressions are immediately invoked. Check out three simple examples that take advantage of immediate invocation. Further, we have assigned lambda expressions. These are invoked indirectly, as you can see from this simple example. Indirectly, invocation can be used to write functions. For example, we can write a function to compute n mod m. The following example is evaluated to 3. We can call this function from other expressions. For example, if we want to compute the greatest common divisor of two numbers, we can exploit the preceding function. The following example is evaluated to 5. Well, lambda expressions can be passed as arguments to methods. In the following example, you call a method named firstLambdaAction that is defined in a bin named lambdaBin and pass to it a lambda expression as argument. As you can see from its code, the given lambda expression is invoked from this method. The invocation takes place via the lambda expression invoked method, which gets as arguments the current EL context and the parameters specific to the invoked lambda expression. Another powerful feature of lambda expressions consists of nested lambda expressions. Check out our example, which contains two lambda expressions. The inner or nested expression is evaluated to 7, while the outer expression that uses the inner expression result is evaluated to 3. The source code that comes with this course contains an application with more than 70 examples of different kinds of lambda expressions. Okay, let's run this code. This table contains the sample data used to write our examples. You can easily close and open anytime this table, so you can compare the data with the output of a specific example. In this application, we covered the new operators, lambda expressions invoke immediately, assigned lambda expressions, and a few more examples that will be discussed in the next video. In this video, we have explored the world of EL lambda expressions. We learned that EL lambda expressions are different from Java lambda expressions, and we wrote several simple such expressions. In addition, we passed lambda expressions as arguments to methods, and we wrote a couple of complex lambda expressions as those invoked indirectly or nested. Well, do you think that EL lambda expression rocks? If yes, then get ready for more. The real power is unleashed only when we bring in our discussion the collection objects. So, in the next video, we will take a closer look on working with collection objects. See you soon. Hi, and welcome to the third video of this section. In the previous video, we looked at EL 3.0 lambda expressions, while in this video, we will take one step further and discuss about working with collection objects. In this video, we are going to take a look at several interesting aspects of working with collections. After a quick introduction, we will write a couple of declarations specific for sets, lists, and maps. Further, we will see some examples of manipulating collections, and we will finish with a dissertation about writing functions with parameters. EL 3.0 provides a powerful support to manipulate collection objects by applying operations in a pipeline. The methods supporting the collection operations are implemented as EL resolvers, and lambda expressions are indicated as arguments of these methods. The main idea behind manipulating collection objects is based on streams. More precisely, the specific operations are accomplished as method calls to the stream of elements obtained from the collection. Many operations return streams, which can be used in other operations that return streams, and so on. In such cases, we can say that we have a chain of streams or a pipeline. The entry in the pipeline is known as the source, and the exit from the pipeline is known as the terminal operation, which doesn't return a stream. Between the source and the terminal operation, we may have 0 or more intermediate operations, and all of them returns streams. The pipeline execution begins when the terminal operation starts. Because intermediate operations are lazy evaluated, they don't keep intermediate results of the operations. An exception here is the sorted operation, which needs all the elements in order to perform sorting tasks. Now let's see some examples. We begin by declaring a set, a list, and a map. As you can see, EL contains syntaxes to construct sets, lists, and maps dynamically, and declaring a set and a list is almost identical, while a map provides a specific syntax that allows us to shape the key value characteristic of a map. Now let's go a step further and sort our list in ascending and descending order. For this, we use the stream, sorted, and toList methods. While the sorted method is like the order by statement of SQL, the toList method returns a list that contains the elements of the source stream, but this time they are sorted. When we want to filter our data, we can use the filter method. This is like the SQL where and group by statements. For example, we can easily filter our set to obtain only the even values, or we can filter our list to obtain only the values divisible by 5. Further, let's say that we have the following list in a bin named lambda bin. Next, we can apply 24% of VAT and compute the total for costs higher than 1,000 using the filter, map, and reduce methods. The map method is like the SQL select statement, while the reduce method is like the aggregate functions. These were just a few examples of using collection objects in EL 3.0. Okay, now let's see an application that contains more than 50 examples of working with collection objects. We have seen this application in the previous video, but we have stopped here at section F. This time, we can go further and explore a lot of examples that uses our sample data to provide different kinds of lambda expressions that are based on collections. But what if we want to take advantage of lambda expressions, but we don't like to write such expressions? Or we want to reuse our lambda expressions in an easy manner? Well, a solution can be to write functions with parameters based on lambda expressions and call them in the GSTL style. For example, the following function is capable of extracting a sublist of a list. Now we can call it as shown in the following code. We can do this multiple times with different parameters. Further, in the complete application that is delivered with this course, you can see a bunch of 21 functions with parameters that can be used with lists. As you can see here, we have functions for sorting, getting a sublist, counting, and so on. In order to exemplify each of these functions, we have called them using a sample data. Now if we run the code, we can see the output of each function, so take your time and explore these examples. In this video, we have covered several aspects of EL 3.0 that involves collection objects. After a brief overview, we learned how to declare collections in EL 3.0 and how to manipulate them via dedicated methods. The last topic discussed in this video was about writing functions with parameters as lambda expressions. In the next section, we will start talking about JSF communication, and the first topic will be focused on passing and getting parameters. So, join me there! Hi and welcome to the section 3 of Core JavaServer Faces course, named Passing and Getting Parameters. We can say that communication is the core of a JavaServer Faces application and is one of the main aspects that dictates the architecture of such an application. So, JSF provides many solutions for ensuring a powerful and flexible communication layer between JSF components and also between JSF and XHTML pages, JavaScript code, and other third-party components. In this section, we will cover 3 topics as follows. We start with the most important types of JSF parameters, and here we will discuss about the context, request, and view parameters. The second topic is related to the flash scope. This scope allows us to pass parameters between user views without the need to store them in the session. The last topic discusses about passing attributes via fAttribute tag handler. This tag handler allows us to pass the value of an attribute of a component or to pass a parameter to a component. So, let's get started. Now we move on the first video of this section that deals with context, request, and view parameters. In this video, we are going to take a look at a different kind of JSF parameters. We will discuss about the context parameters used for initialization goals, continue with the request parameters that have a short lifespan but are very useful for generating query strings and messages with parameters, and finish with the view parameters that sustain bookmarkability in JSF applications. In addition, we will have a quick look over passing parameters via method expressions and some hints about the binding attribute. The context parameters, also known as initialization parameters, are typically used for initialization purposes at application level. They are declared in web XML file using the context param tag. This tag supports two important children: param name, which indicates the parameter name, and param value, which indicates the parameter value. Also, notice that these kind of parameters are not specific to JSF, being accessible from outside of JSF, for example, from a servlet. Most of the time, such parameters are used for providing different configurations. For example, JSF comes with a list of built-in context parameters that can be used to fine-tune the JSF environment. Here you can see the project stage context parameter, which allows us to specify if our application is in production or development stage. For example, a user-defined context parameter looks like in the following code. The parameter name is number 1 in ATP and its value is Rafael Nadal. Now you can use in your application the name of the number 1 in ATP, and if number 1 in ATP changes, then you can quickly align your configuration by modifying its name in WebXML. In addition, the context parameters also supports EL, as you can see in this example. We can access the context parameters in JSF pages or in bins. In JSF pages, we can use the implicit object initParam, or we can use the external context API. As you can see, both examples will return the value of the same context parameter from the initialization parameters map. If we are using the initParam implicit object without arguments, then we will obtain the entire initialization parameters map. Now in a bin, we can obtain the value of a context parameter via JSF API like this. In addition, we can obtain all the context parameters by calling the getInitParameterMap method, which returns a map whose keys are the set of application initialization parameter names, and whose values are the corresponding parameter values. As we said earlier, the context parameters are not specific to JSF, and they can be accessed outside the JSF environment. For example, you can access them via the HTTP servlet request object, or in a servlet via the servlet config object. Check out these two examples. As a note, try to keep the context parameters at application level for initializations and configurations, and not use them in place of the data model or for storing the user credentials. In this sample application, you can see three approaches of extracting the value of the context parameter named number 1 in ATP. In the first approach, we are using the initParam implicit object. In the second approach, the initialization parameter map, and in the last approach, the getInit parameter method. Now let's run the code. Notice that all three approaches returned the same result, which is exactly what we expected to see. Basically, the request parameters are parameters attached to a GET or a POST request. In a GET request, they appear in the query string of the request, and they are visible in the browser address bar as request query parameters. Usually in JSF, they are attached to GET requests via fparam nested in tags like hlink or hbutton. The request parameters in POST requests are not visible in the browser address bar, and in JSF they commonly represent values of the submitted components, but they can be explicitly submitted by nesting fparam in tags as hCommandLink or hCommandButton. Programmatically speaking, the request parameters are available in all JSF faces via the external context methods. Well, let's see how we can attach several request parameters to a GET request, or more exactly, how we can generate a query string. The fparam tag can be used to pass request parameters directly between facelets, without involving a managed bin. Usually, this happens in the hlink tag, as shown in this piece of code. When the San Rafael Nadal link is clicked, JSF will use the prepared URL containing the result HTML view and the request parameters player name param and player surname param. If you check in the browser address bar the URL generated by the hlink tag, then you will see something like the following URL. Notice the generated query string, which is highlighted in red, and keep in mind that by default the query string doesn't participate in postbacks. Notice that fparam tag cannot be fortified with declarative or imperative validations and conversions, so you need to accomplish these kind of tasks by yourself. Also notice that we cannot place the fparam tag inside the hinputText tag or any other input component. That will simply not work. Now let's talk about the request parameters in POST requests. In JSF, we can easily trigger a POST request by submitting a form, like this one. When the register button is clicked, a POST request will transport the data provided by the user from the client side to the server side. In order to accomplish this task, each piece of data is stored in a request parameter. As you can see highlighted in red, each POST request parameter has a name that reveals the form ID and the component ID whose data it transports over HTTP. Further, in the Apply Request Values phase, JSF inspects these request parameters and extracts the request values for each component in the component tree. By calling the setSubmittedValue method, the request values are stored locally in components. This process is known as decoding. Now let's talk about adding request parameters explicitly to POST requests. Typically, you will use fparam nested in hCommandButton or hCommandLink for submitting some extra parameters that doesn't make sense to appear in the managed bin properties, and they have to be removed once the current request response lifecycle is over. Nevertheless, you probably need them for some business logic in the methods of your bins. For example, we may need them in an action method named registerAction. Notice that these request parameters doesn't appear in the query string of the URL, since they become part of the POST request that submits the current form. Basically, they are available in the request parameter map next to the request parameters that corresponds to the submitted components. The fparam tag can also be used inside the houtput format tag to create messages with parameters. At runtime, JSF will replace the placeholders from the message with the values of the parameters, exactly as you can see in this example. In order to access the request parameters in JSF pages, we can use the param and param values implicit objects. If we want to access a certain request parameter by name, then we simply extract it from the request parameters map like this. In beans, the request parameters are available via three methods. First, we have the getRequestParameterMap method, which returns an immutable map whose keys are the set of request parameters names included in the current request, and whose values are the first or only value for each parameter name returned by the underlying request. Next, we have the getRequestParameterValuesMap method, which returns an immutable map whose keys are the set of request parameters names included in the current request, and whose values are all of the values for each parameter name returned by the underlying request. And finally, we have the getRequestParameterNames method, which returns an iterator over the names of all request parameters included in the current request. In order to access a specific parameter by name, we can simply call the get method over the request parameters map, as in this example where we extract the value of the player name param request parameter. If you think that is not a very convenient approach to access the request parameter map in the bin, then you can use the managed property annotation, which sets the parameter as a bin property. The values are set immediately after the bin's construction and are available during post-construct. But keep in mind that the managed property annotation is usable only with bins managed by JSF, not with bins managed by CDI. Now, let's check out a classical usage of request parameters via a sample application. We simply generate a getRequest via HLink tag and pass two request parameters via fparam. These parameters will appear in the query string of the getRequest. Now let's run the code. When we press the Send Rafael Nadal link, the application will navigate in the result page. Notice the query string of this request and the fact that the passed values are available in page. We have obtained them via the param implicit object. Okay, now let's talk about view parameters. This kind of parameters have been added starting with JSF 2.0 and are used in page via the fViewParam tag. They appear nested in the metadata section, and their main goal is to sustain the developer to provide bookmarkable URLs. Usually, even if it is not mandatory, they are initialized via request parameters that are fetched by name. This means that the view parameters can be a workaround to avoid losing the request parameters values that comes via query strings of get requests. It's like JSF is asking you to point out the request parameters from the query string of this get request that contains values that must live across past requests. View parameters are shaped by UI view parameter class, which is an extension of UI input class. This is major because view parameters values can be converted and validated before they reach managed bins. Practically, they act as UI inputs. In addition, it is important to know that view parameters are stateful and they can be included in the query string of an URL. Well, learning by example is the best approach for understanding how to work with view parameters. Here it is a simple example. In page A, we have a link that generates an URL that points to page B and contains a query string with a single request parameter named myParamName. As long as we define in page B a view parameter with exactly the same name, myParamName, JSF will initialize this view parameter with myParamValue. Further, the view parameter will initialize the my property of myBin. In addition, view parameters supports built-in and custom converters and validators. As you can see in this code, we can easily attach a custom converter and a custom validator by using the converter and validator attributes. In getRequests, and when we navigate to another page via redirect, which in the end also results in a getRequest, we can easily attach the view parameters as a query string by using the includeViewParams attribute in HLink and HButton. Or we can use the includeViewParams request parameter in any URL. For example, we can use it in HLink, HCommandButton, or in an outcome returned by an action method. Further, let's see a simple and common use case of view parameters. Let's suppose that we have the following code and we want to understand what is happening here. First, the request parameters names matches the names of the view parameters. So the view parameters take the request parameters values and finally stores them in the player's bin under the player name and player surname fields. So we set the managed bin fields via view parameters. Further, the view is displayed so we can see Rafael and Nadal in the text inputs, since they are fetched from the properties of the managed bin. Next, we can manually modify these values in the text inputs or leave them like that. Now when we click on the send button, we practically submit the form with the current values. So, the name and surname are submitted and override the current values in the data model. During rendering the view, JSF will encode view parameters against the player's bin. Further, JSF will see that we want to attach the view parameters before navigating to the results XHTML page. The view parameters have been evaluated against the player's bin earlier in this request, so JSF processes the view parameters and attaches the corresponding query string computed from view parameters names and values to the action URL. Further, JSF navigates to the target URL, which now contains the query string. This is visible in the browser address bar thanks to Faces redirect equal true. Now let's see a sample application. In this case, we initialize the view parameters from the query string. Further, when we press the submit button, the view parameters are included via includeViewParams, and the application will navigate in the results page. While this is a post request, the same thing is accomplished via a get request using HLink and includeViewParams attribute. Let's run the code. First, we manually provide the query string that contains the needed parameters. Further, let's press the button. As you can see, everything works as expected. The view parameters was attached in the query string and their values are available in page. Further, let's talk about passing parameters using method expressions. This is just a great solution for sending parameters as arguments to an action method of a managed bin. For example, let's focus on the following snippet of code. As you can see in this code, the action attribute indicates a method that gets two arguments. This can be a void action method, or it can return an outcome. In the same manner, you can pass numbers or objects. Now JSF components support an attribute named binding, which is not very used and sometimes is not understood correctly. If we want to localize the moment in time when the binding attribute enters the fray, we can refer to the moment when the JSF view is built or restored. The result of building, restoring the view is present in the component tree. So, before the component tree is available, JSF needs to inspect all the bindings attributes. For each of them, JSF will check the presence of a pre-existing or pre-created component. If such component is found, then it is used. Otherwise, JSF will automatically create a brand new one and will pass it as an argument to the setter method that corresponds to that binding attribute. In addition, JSF adds a reference of the component in the view state. Further, a postback request, a form submit, will tell JSF to restore the view, which will restore the components and the bindings based on the view state. Now that you know what happens with the binding attribute, let's have some important aspects of using it. First, you have to know that after each request, initial or postback, JSF creates an instance of the component indicated by the binding attribute. Next, in the restore view phase, after the component instance is created, JSF will populate it from the view state based on the stored reference. When we bind a component to a bin property of type UI component, we actually bind the whole component. This kind of binding is not very used, and it may be useful when we want to work or expose the methods of the component that are not available in the view, or we need to alter the children of the component in a programmatical fashion. In addition, we can alter the attributes of the component and instantiate the component in place of the page author. Since JSF will instantiate the component at each request, the bin must be in the request scope, otherwise the component may be shared between different views. The view scope may also be a solution. But the binding attribute is also used to bind the component to the current view without the need of a bin. This is useful to obtain access to the state of a component from another component. Binding a component without a bin property will put the component in the EL scope. This happens when the component tree is built, so EL is perfectly capable to reveal the bound component at the rendering stage, which takes place after the component tree was built. For example, a data table tag has three useful properties. First, rows and row count. If we bind a data table tag to the current view, then outside of this component, we can access these properties as shown here. For example, we can set the rows property as follows. Or we can display the row count and first properties as follows. Now, even if it is not recommended, we can accomplish the same thing from a bin. First, we bind the data table tag to a bin property of type HTML data table. And in player's bin, we add the following code. Now JSF will automatically accomplish the binding tasks. In this video, we have explored several aspects that involves JSF communication via parameters. We have started with the context and request parameters, continued with view parameters and passing parameters as arguments in action methods, and finished with a nice overview of the binding attribute. In the next video, we will discuss about passing parameters using the flash scope. So, join me then. Hi and welcome to the second video of this section. In the previous video, we looked at passing and getting context, request and view parameters. We have also looked at passing parameters as arguments in action methods and at the binding attribute. In this video, we are going to take a look at the flash scope, and we begin with a quick introduction meant to shape the main aspects of this scope. Further, we will suppose a scenario that can be easily implemented using the flash scope, and here we will discuss about putting, polling, and keeping data with respect to the flash scope features. Let's say that for those who are familiar with SIM, the flash scope is very similar to the temporary SIM conversation. With other words, the flash scope is a very handy tool when you need to pass parameters over a redirection without storing those parameters in the session. The parameters stored in the flash scope will be available over a single redirection, and they will be discarded afterwards. This is really useful when we are implementing a post-redirect get pattern. Now, for a better understanding, let's suppose the following scenario. A tennis player needs to register on the ATP website. Among other information, he will provide his name and surname and click on the register button. This is accomplished in the index.html page. The application flow redirects the player to the page terms.html. On this page, the player can see a welcome message containing his name and surname and some terms and conditions that must be accepted using the accept button or rejected using the reject button. Now, if the reject button is clicked, then the player is redirected to the index.html homepage, and the form registration fields will reveal the information provided by him earlier. In addition, he will see a generated message stating terms rejected, player not registered. This is outputted by the h-message tag. Now, if the accept button is clicked, then the user is redirected to a page named done.html. On this page, the user will see a generated message stating terms accepted and player registered, and another message stating name surname successfully registered. The first message is outputted by the h-message tag, while the second one is by the h-output text tag. Mainly, we can implement this flow only if we store the submitted values somewhere, because they will not survive during the redirect process. This means that using a managed bin in the request scope cannot be a valid option. But if we bring into discussion the new flash scope, then we can use a request scoped managed bin. In our example, we will use the flash scope to transport the player name and surname across redirections. So let's use this case to learn how to work with the flash scope. In order to store some information in the flash scope, we use the put method. As you can see, this works like a Java map, having a key and a value, and the key will help us later to locate the value. We can easily store the player name under a key named player name and the player surname under a key named player surname. In order to access the information stored in the flash scope, we use the get method, exactly as we use it for accessing data from a Java map. The information taken from the flash scope can be used to initialize the properties of the bin. We can also get the data from the flash scope in page. This can be accomplished via the flash implicit object, as you can see in these two examples that pulls out the player name and surname. As you already know, the data stored in the flash scope will survive across a single redirection. Well, if we want to instruct JSF to keep this data across one more redirection, then we can use the keep method and pass to it the key that corresponds to the value that must survive to the next redirection. For example, we can keep the player name and surname as in this example. In addition, we can instruct JSF to keep the Faces message instances queued in the current Faces context. This can be done via the setKeepMessages method. The Flash API allows us to check if the Faces messages will be kept across the next redirection via the isKeepMessages flag method. We can easily obtain the same effect from a JSF page by using the Flash implicit object as in these examples. Now let's sketch the main aspects of implementing our example. First, we have to store the player name and surname. In the data model, this information is stored in the request scope via the bin named playersBin. But remember that we need the name and surname to survive to the first redirection that occurs when we press the register button. Further, when we press the accept or reject button, the same data must survive to the second redirection. The request scope cannot help us to achieve this goal, so we can use the Flash scope, which fits well to our scenario. When we press the register button, we can simply call an action method that puts the submitted name and surname in the Flash scope via the put method. Also, notice the last line of code, which fires a redirect to the terms page. When the application flow arrives in the terms page, the data from the Flash scope should be discarded. But while navigating from the terms page back to the index or further to the done page, we want to keep the name and surname available to the next redirection. For this, we need to instruct JSF to keep this information in the Flash scope. And an easy way to accomplish this consists in using the Flash implicit object in the terms page. Actually, at the line highlighted in red, we display the values of the player name and surname from the Flash scope, and we instruct JSF to keep them in the Flash scope for the next redirection, which can point to the index or to the done page. In addition, when the accept or reject button is clicked, we call an action method that is capable to take the application to the next step. So, when the accept button is clicked, we need to perform several tasks. First, we add a Faces message that reports the success of registration. Since we will fire a redirection to the done page, we need to instruct JSF to keep the messages in the Flash scope. Otherwise, the messages will be lost during this redirection. Further, we initialize the properties of the bin that corresponds to the player name and surname with the values from the Flash scope. This is happening via pull values from Flash action method, which is discussed a little bit later. Notice that we don't do anything in the bin with these properties, but in a real case, we can use these properties to accomplish other tasks. Okay, now for the reject button, the implementation is almost the same. Actually, we just fire another message that reports the rejection of registration, and we navigate via redirection to the index page. Next, let's check out the pull values from Flash action method. This method is used to initialize the bin's properties with the values from the Flash scope. Basically, we call this method from the index and done pages via the pre-render view event. So, before rendering these views, we tell JSF to initialize the player name and surname properties from the Flash scope. This allows us to use these properties in page without getting null values. After we are gluing all this information, we obtain an application like this one. As you can see, the story begins in the index page and continues in the terms page. Here we can accept or reject the terms, and depending on our choice, the application will navigate back in the index page or further in the done page. The process is orchestrated by the server-side request-scoped player bins via the following methods: add values to Flash action, pull values from Flash action, terms accepted action, and terms rejected action. Now let's run the code. We simply provide the name and the surname and click the register button. The address bar displays the terms page in the URL, which is a signal that a redirection took place. But in the same time, notice that the past information are available. They were not lost during redirection. Now let's fire another redirection by pressing the accept button. Again, the address bar reveals the done outcome and the information are still available. So we can say that the flashscope has successfully accomplished its goal. In this video, we have learned about the flashscope. In order to dissect the flashscope features, we have started with a quick introduction, followed by an example meant to show you how to put, pull, and keep data via the flashscope. In a learning by example fashion, we have covered the main aspects of the flashscope, and at the end, we have obtained a complete application. In the next video, we will discuss about passing attributes via the f-attribute tag handler. So, join me there. Hi and welcome to the third video of this section. In the previous video, we discussed about working with the flashscope. In this video, we will talk about passing attributes via the f-attribute tag handler. Mainly, in this video, we are going to see a bunch of use cases for the f-attribute tag handler. After a quick introduction and a simple use case meant to get you familiar with this tag handler, we will see how to use f-attribute for passing parameters or setting unsupported attributes to a JSF component, passing extra parameters to a custom validator, setting a component renderer from page, and so on. As you can see, we have a pretty big list to cover, so let's get started. The f-attribute is a tag handler. Basically, a tag handler is just an optional piece of code executed when JSF meets a built-in or custom tag in the JSF page. A tag handler is capable to access and modify the JSF component tree that is currently built, but you have to keep in mind that when a tag handler is executed, the component tree is partially built, restored, which means that some components exist while others doesn't exist yet. A tag handler is useful when you need to pinch some components from the component tree. For example, the f-attribute tag handler allows us to pass the value of an attribute of a component or to pass a parameter to a component. If the value specified is not a literal, it will instead set the value expression on the UI component. Now let's see a simple and pretty dummy use case. Here we use the f-attribute to set the style and value attributes to the h-output text tag. The values of these two attributes are provided by the following bin. So, based on this example, you can set any attribute of any component. As you can see here, the component tree reveals the values extracted from the data model, or more precisely from my bin. In addition, you can see that the value and style attributes are attached to the output text component next to other attributes of this component. So at the rendering time, we will see the text Hello World highlighted in green. The f-attribute tag can be used to pass parameters or set unsupported attributes to a JSF component, as shown in the following code. It's obvious that the player name and player surname attributes are not supported by the command button. Nevertheless, we can access them from a bin via the getAttributes method. Okay, let's check out this example via a sample application. In the index page, we simply attach 3 attributes to a command button. The value attribute is one of the supported attributes of a command button, while the player name and player surname are not supported. These attributes should be available after submit in the parameters action method. So, let's run the code. Check out the button label and notice that the value attribute was set. Further, we just press this button and take a look at the server log, which reveals the values of the other two attributes. Now let's talk about passing extra parameters to a custom validator. In this example, you can see how to use the f attribute to pass 3 extra parameters to a custom validator. Basically, the user will select one of the 3 names from the menu and will submit the form. He also submits our 3 attributes that have their names built from a prefix plus the player name. In the validation phase, we throw an error whose message is dynamically generated based on the selected player name and the text that is fetched from one of the 3 passed attributes. Further, let's talk about cross-field validation, which is a real challenge in JSF 2.2. A common example consists in validating a password or a bank account against its confirmation. The big issue consists in the fact that we cannot give to a single validator the bank account and the confirmation in the same time. A quick approach will involve the binding attribute and the f attribute tag handler. Via the binding attribute, we can bind the confirmation component to the current view, and via the f attribute, we can attach the bound component to the parent component of this f attribute. Further, in the validator, we have access to the confirmation of the bank account via this attribute. Another case when the f attribute tag can be useful is when we need to dynamically pass parameters together with components bound to a managed bin using the binding attribute. This is very useful, especially because there is no solution provided by JSF for passing parameters to the getters and setters methods of the bound components. Now the value of the h_input_text tag should contain the value set via the f attribute tag. Pay attention to use only unique names for the attributes and to not interfere with the default attributes of the component. Now let's talk about setting a component renderer from page. In order to understand this use case, let's suppose that we have the following 2 input components. By default, both of them will be rendered via the renderer identified by the JSF Faces text renderer type. But let's suppose that we want to use the default renderer for the first input component and the custom renderer for the second input component. Well, we can try to use the renderer type attribute, but you will notice that this doesn't work. Actually, this is expected to work someday, most probably when it will be listed in the taglib file which the tooling depends on. But we can alternatively use f attribute for this task. Simply nest the f attribute in the second input component and set the renderer type attribute like this. Now let's have another topic. Well, when you need to use a navigation case to enter in a flow, you will have to specify the toFlow document ID statement nested in the navigation case tag. In addition, a button or a link can be used to enter in such a flow, as you can see in this piece of code. If you choose to write a programmatic navigation case, then JSF 2.2 comes with a method named getToFlowDocumentID. This method should be overridden for indicating the document ID. Well, this was the last use case. I really hope that this bunch of examples were useful and that you understood how to work with the f attribute tag handler. In this video, we have covered the main aspects of working with the f attribute tag handler. After a quick introduction, we have dissected several use cases of this tag handler, such as passing extra parameters to a validator and setting a component renderer from page. Well, since this is the last video of this section, let's say that in this section we have covered the most important aspects of passing and getting parameters in JSF. We started with the context, request and view parameters, continued with passing parameters using the flash scope, and finished with this video about passing attributes via f-attribute. In the next section, we will continue our journey through JSF communication capabilities. So, we will discuss about actions, cookies, and hidden fields. See you soon! Hi, and welcome to the section 4 of Core JavaServer Faces course, named Actions, Cookies, and Hidden Fields. In this section, we will take JSF communication one step further, and we will cover 4 more topics. We start with a new feature of JSF 2.2 that allows us to call actions on GET requests. We will continue with setting property values via action listeners and with sending data via cookies. The last topic of this section is reserved to sending data via hidden fields. While JSF 2.0 has improved the support for GET requests with hlink, hbutton and view parameters, JSF 2.2 addresses another important aspect. This aspect refers to the view actions or how to call actions from GET requests. So now we move on to the first video of this section that deals with calling actions on GET requests. In this video, we are going to take a look at 3 main aspects of the view actions. First of all, the view actions are declared in the metadata section as the view parameters. So, we start with a short dissertation about what is actually the metadata section. Further, we will write an example of using the view actions, and we will finish with a comparison between the well-known pre-render view and view actions. This will reveal the main differences between these 2 artifacts. So, by definition, metadata refers to data that provides information about other data. Some of the supported metadata needed by the current view includes locale, content type, encoding, render kit, phase listeners, and so on. Some of the metadata, such as the JSF 2.2 stateless mode, are per attribute based metadata that can be set via the fView tag, while the goal of supporting view parameters and actions implies complex metadata. Since the fView tag cannot handle such complex metadata, JSF 2.0 comes with the view metadata facet. This is created only once per view at initial request and is not recreated on postbacks. Well, after the view parameters have been added, the view metadata facet also gets a shortcut for the facet form. This is the fMetadata tag. The current view metadata doesn't participate in XHTML templates, which means that the page author must ensure that the fMetadata element doesn't appear on a template or included page. So it lives in the view and can appear in a template client as a direct child of fView. The fMetadata is just a way of configuring the view parameters and actions that should take place before the view is rendered and without the user interaction. So fMetadata is perfect for initializing the current view and executing actions based on the information provided from previous views. In a common scenario, we will have some view parameters that instructs JSF about how the request parameters should be handled when a view is either requested or linked. Next to the view parameters, in the meta model we have view actions. The story behind view actions is pretty simple. The view parameters cannot provide action invocation and navigation, which implies lazy loading of the data. In JSF 2.0, this problem was fixed via the fEvent tag, but this tag has several issues. For example, the pointed listener is invoked at each request, it doesn't support navigation, and so on. So starting with JSF 2.2, we have the view actions, which can be part of the JSF lifecycle for faces and non-faces requests. We can use view actions for validation, loading specific data, initialize artifacts, and so on. In this example, we are using a view action to invoke a method that is responsible to validate two view parameters. We can easily modify this example to load the specified player from the database or to accomplish any other specific task. Of course, we can also use view actions without view parameters. They work very well together, but they don't depend on each other. With other words, the view actions can be placed into a view metadata facet that doesn't contain view parameters, and vice versa. Okay, so let's see this example in a sample application. First, we have our view action that invokes a server-side method capable to validate two view parameters. As you can see here, this method is very simple and it just simulates a validation result via a random integer. So let's run the code. We need to initialize our view parameters, and for this we can quickly add a query string. Every time we fire the refresh button, the validate data method is invoked, and this method will randomly generate a validation error message. Okay, let's go further, and now let's see the main differences between the view actions and the pre-render view event listener. Sometimes we can use the view actions to obtain the same effect as using pre-render view, and vice versa, but this doesn't mean that they act the same. One of the major differences between them consists in the fact that the pre-render view is always executed on postback requests, while the view actions are executed at initial request and only on demand at postbacks. Now let's talk about navigation capabilities. While the pre-render view event listener doesn't support navigation, the view actions does it quite well. The action methods associated with view actions can return outcomes, and declarative navigation is also an option. The third difference consists in the phase when pre-render view and view actions are executed. While the pre-render view is executed at the beginning of the render response phase, the view actions can be executed in the invoke application phase or in the apply request values phase. The view actions can be executed in different phases by using the phase attribute. On the other hand, the fEvent can be processed depending on the value of the type attribute, which in our case is set to pre-render view. While the pre-render view is executed at each request, the view actions can be executed conditionally via the if attribute. And the last big difference between these two JSF artifacts consists in the fact that the fEvent is a tag handler, while the fViewAction is an UI component that will be a part of the component tree. In this video, we have covered the view actions topic. After we have discussed about the metadata section that hosts view actions, and we've done an example, we have finished with a comprehensive comparison of pre-render view event listener and view actions. In the next video, we will talk about setting property values via action listeners. See you soon! Hi and welcome to the second video of section 4. In the previous video, we look at calling actions on GET requests, or shortly at view actions. Further, we will discuss about setting property values via action listeners. Mainly in this video, we are going to see a bunch of use cases for the fSetPropertyActionListener tag handler. After a quick introduction and a simple use case meant to get you familiar with this tag handler, we will see how to use fSetPropertyActionListener for setting a managed bean property value to another property value from the same bean and from another bean. The last topic will consist in an example of removing an item from a list of items using this tag handler. So let's get started with the quick introduction. In order to set the property values via action listeners, we are using a tag handler named setPropertyActionListener, whose coordinates are the following tag classes and tag handler classes. The fSetPropertyActionListener tag uses an action listener created by the framework to directly set a value into a managed bean property. It is placed in a component obtained from the action source class. The target attribute indicates the managed bean property, while the value attribute indicates the value of the property. It is important to keep in mind that action listeners are executed in the order of definition, which means that the presence of fSetPropertyActionListener tag can affect the order in which the listeners are fired. Now let's see a simple use case of setPropertyActionListener. Basically, we want to set a static text to a managed bean property. For this, let's suppose that we have a bean named PlayersBean with a property named PlayerName, which is initialized with the text Rafael Nadal. So at initial request, this is the text that we can display on page. Further, we press a command button that uses the setPropertyActionListener to set the text Roger Federer to the player name property. Notice how we have specified this text in the value attribute and how we have informed JSF about the bean and the property where this text should be stored via the target attribute. Now this is the text that will be displayed. The setPropertyActionListener can be used to set a managed bean property value to another property value from the same bean. In this example, we have two properties defined in the player's bean. One is of type string and the other one is of type player. And we use the setPropertyActionListener to assign the value of the string property to the player property, or more precisely, to the name property of the player property. Here we have a pretty similar case, only that this time we have two managed beans. And we use the setPropertyActionListener to set a property value from the player's bean to a property value in the tournament's bean. Now we know that setPropertyActionListener allows us to set a property value directly in a managed bean before executing an action method. Based on this behavior, the setPropertyActionListener can be used in combination with command button or command link for setting the user selection from a list of multiple options before further processing. So, check out this example. Each time a user clicks on the delete icon, the fSetPropertyActionListener tag sets the managed bean selected player property with the player value associated to the selected icon. This is happening before the action method is invoked. Afterwards, the command link fires the execution of the removePlayer action method. This method searches for the selected player set via setPropertyActionListener and removes it. Now that we have finished the examples, let's see a sample application. The following sample application sets a static text to a managed bean property. As you can see in player's bean, the player name field has an initial value equal with Rafael Nadal. But in our index page, we explicitly set this field to Roger Federer via the setPropertyActionListener. Now let's run the code. So the initial value is displayed and all we have to do is to press this command button. The effect of setPropertyActionListener is available right away, as you can see on page and on server-side log. In this video, we have covered the main aspects of working with setPropertyActionListener tag handler. After a quick introduction, we have dissected several use cases of this tag handler, such as setting a managed bin property value to another property value from the same bin, and removing an item from a list of items. In the next video, we will discuss about sending data via cookies. See you soon! Hi, and welcome to the third video of section 4. In the previous video, we look at setting property values via action listeners, while in this video, we will discuss about sending data via cookies. We start with a quick overview meant to point out the headlines of cookies and how JSF stores them. Further, we will discuss about creating, setting, expiring and getting cookies via the JSF API. By a cookie, we may understand a small piece of information that a web server gives to a web browser. After creation, which is basically a text file, the web server can read content from the cookie and write content to it. Most commonly, cookies are encrypted and are used to identify the users, but generally speaking, they can be used for remembering different kinds of settings specific to a client machine, such as configuration and history. It's important to know that the web servers can access cookies which are set to their own domain. The domain is set by the web browser when a new cookie is requested by the web server. While cookies cannot be shared between domains, they can be shared between subdomains if this is explicitly required. Among cookies limitations, we have the size, the number of cookies per domain, which is usually around 20 cookies, the number of cookies per hard drive, which is usually around 300 cookies, and the expiration date. In order to instruct the web browser to create a cookie, a web server should send the HTTP response that contains a part dedicated to this goal. This part of the HTTP response is made of several hints or options. First, we have the set cookie, which basically instructs the web browser to create a new cookie. Next, we have the name of the cookie and the content that the web server wants to store on the client machine. This content can be a string or a number up to 4 kilobytes in size. Okay, now the further hints are optional. First, we have the version attribute, which represents the version of the cookie protocol. Further, we have the path of the cookie. This is pretty similar to the domain option and indicates an URL path that must exist in the requested resource before sending the cookie header. Next, we have the domain of the cookie. By default, the domain is set to the host name of the page that is responsible to set the cookie. The explicit need of setting the domain value implies the need to share a cookie across multiple subdomains. Further, we have the secure option. This is a flag that should appear in the response only when we want to send the cookie to the web server if the request was made using SSL and the HTTPS protocol. Next, we have the HTTP only flag. The goal of this flag is to reduce the risk of client-side script accessing the protected cookie. Notice that JSF has implicit support for preventing cross-site scripting attacks. Finally, we have the expiration time that instructs the web browser about the moment in time when the cookie should be deleted by the browser. Without the max age option, a cookie has a lifespan of a single session. When a cookie lives over multiple sessions, we say that it is a persistent cookie. Notice that if the max age is set to a negative value, then we have a session cookie, and if it is set to 0, then the cookie is immediately deleted. In order to create a cookie, we can easily exploit the cookie class. This class provides special getters and setters methods for getting and setting the cookie attributes. We can group these methods and obtain a helper method as the create cookie listed here. For start, we ensure that the name of the cookie is not null or empty. Further, we ensure that the value is not null and we encode it. We need to encode the value in order to avoid undesirable results, such as cookies with white spaces will get codes on client machine. If the name and the value are valid, then we can create the cookie instance via the constructor of the cookie class. Next, we will add the optional attributes of a cookie. We start with the domain attribute, which can be provided as an argument of the create cookie method, or we can set it to the current host, as you can see in this piece of code. Further, we set the path and the secure attributes. If the secure attribute is not specified, then we try to detect it via the isSecure method. Next, we set the HTTP only and the version attributes. The HTTP only attribute is recommended to be set to true for all cookies created by the server side. And the last part is reserved to the comment and the expiration time attributes. Okay, so now we can use this helper method to create different kind of cookies. For example, we can create a session cookie for current domain or a persistent cookie for a subdomain. So we can use our helper class to create some cookies. Next, we need to add these cookies to the response, and for this we can use the add cookie method from the HTTP servlet response class. Since the code for obtaining the current response object is pretty verbose, we can write a simple helper method as our getResponse. Further, we can use this helper method to add cookies in the current response. Another approach for setting a response cookie is based on the external context addResponseCookie method. Basically, we need to define a map containing the optional attributes that shape our cookie and invoke the addResponseCookie method using the cookie name, value, and this map. In order to get all the available cookies, we can use at least two approaches. One of these two approaches consists in calling the HTTP servlet request getCookies method. In a JSF page, we can chain several artifacts into a value expression and obtain the same result. Another approach consists in using the external context getRequestCookie map. Basically, this method returns an immutable map whose keys are the set of cookie names included in the current request, and whose values are the first or only cookie for each cookie name returned by the underlying request. This map is managed by JSF, and it is also available in page via the cookie implicit object. Now let's see how we can get a specific cookie. In this example, we wrote a helper method that returns the cookie instance that corresponds to the passed name. Basically, this helper method loops the array of currently available cookies and tries to find a cookie with the same name as the one passed here as an argument. But most commonly, we want to get the value of a specific cookie instead of the instance. For this, we can call our getCookieInstanceArray helper method to obtain the cookie instance and afterwards simply return the decoded value of this cookie. If we want to obtain a specific cookie instance from the cookies map, then we can use this helper. In order to obtain the value of a cookie, we can also call our getCookieInstanceMap helper method to obtain the cookie instance, and afterwards simply return the decoded value of this cookie. Now in a JSF page, we can easily loop and search for a specific cookie via the cookies array using the C for each GSTL tag or the UI repeat component handler. The same thing can be accomplished by applying C for each or UI repeat to the cookie implicit object. Sometimes we need to explicitly remove a cookie. In such cases, we need to set the value of the cookie to null and the expiration time to 0. In addition, if we have specified the path when the cookie was created, then we need to specify it again. So, we can accomplish this goal via a helper method like this one, or like this one. Okay, let's check out a sample application that sets two cookies. First, notice the helper class that we have discussed earlier in this video. Actually, this is a partial implementation based on the HTTP servlet request and HTTP servlet response that contains only the create cookie and set cookie instance methods. Further, we are using these two methods to create and set a session and a persistent cookie. So, let's run the code. Before pressing the Add Cookies button, we can open this browser tool that is capable to display the current cookies. As you can see, there is none of our cookies listed here. Now, let's press the button for creating and adding our cookies. So notice that both cookies were successfully added, which means that our job here is done. In this video, we have covered the main aspects of working with cookies in the JSF environment, such as creating, setting, getting, and removing a cookie. In the next video, we will discuss about sending data via hidden fields. So, see you soon. Hi and welcome to the last video of this section. In the previous video, we had a comprehensive overview about working with cookies in JSF. In this video, we will cover the last topic of this section that is reserved to hidden fields. After introducing the hidden fields and shaping several aspects of their goals in an application, we will discuss about working with hidden fields from HTML and JSF perspective. Basically, by hidden fields, we understand just input text fields that are not visible on the page for the user. Even if the corresponding HTML code is available in the page source code, the user is not aware about the presence of the hidden fields, so the user cannot type anything in a hidden field. So hidden fields are commonly used for submitting data in a silent manner and can be the perfect choice for dealing with temporary data or information provided by the user that should be used again and again. In order to render a hidden field, JSF provides the HInputHidden tag. One of the well-known predefined JSF hidden field is named JavaServer Faces viewState. When we talk about this hidden field, we need to talk about saving the state. Well, saving the state on the server means to save it in a session with a special ID, known as the viewState ID, that refers to the state stored in the server memory. This is sent to the client as the value of the JavaServer Faces viewState hidden field. On the other hand, if the state is saved on the client, then JSF stores it as the value of the same hidden field. This value is a base 64 encrypted string representing the serialization of the state. In order to write a hidden field, we can use plain HTML code as in this example. This approach is useful if we don't need to link the value of the hidden field to a property of a bin. But when we need to have the hidden field in the component tree and to be linked with a property of a bin, then we should use the JSF HInputHidden tag. Well, the HTML hidden fields are stored in the request parameter map and their names become keys in this map. In order to extract the value of an hidden field on the server side, we can simply call the get method and pass to it the name of that hidden field. As you can see in this example, we can easily use hidden fields to set or initialize the properties of a managed bin. On the other hand, if a JSF hidden field points to a bin property, then on submit, JSF will automatically set that property via the setter method, exactly as it does for a JSF text field. Now, of course that the JSF hidden fields are available in the request parameter map via the corresponding client IDs, but is not recommended to use JSF hidden fields for setting static data. In order to get on the client side in JavaScript the value of an HTML hidden field, we can use the document getElementById function and the corresponding ID of the hidden field. The same approach can be used for JSF hidden fields, only that instead of IDs, we need to refer to the client IDs of the hidden fields components. Okay, now as you know, the hidden fields are not visible to the user, and the user cannot type in a hidden field. A common practice used to set the value of a hidden field on the client side is to call a piece of JavaScript right before submitting the form. This piece of JavaScript can access the hidden field and set its value. We can refer HTML hidden fields via IDs and JSF hidden fields via client IDs. As a sample application, let's see the case of setting JSF hidden fields via JavaScript. So our hidden fields are initially set from players bin as Roger and Federer. Now, when we press the send button, the set hidden values is called thanks to the onClick event. Right before submitting the form, this piece of JavaScript will set the player name to Rafael and the player's surname to Nadal. After submission, the player name and surname are displayed in the result page. So let's run the code. Initially, we see the text Roger Federer, which is normal. Further, let's press the send button and see what happens. The hidden fields were successfully set via JavaScript and their information was used to modify the player name and player surname fields to Rafael and Nadal. So our hidden fields worked as expected. In this video, we have discussed about working with hidden fields in JSF. After an introduction into this topic, we have learned how to get and set the value of a hidden field on client side via JavaScript and on server side via the JSF API. Well, this was the last video of this section. In the next section of this course, we will end our journey in JSF communication capabilities, and we will discuss about managed bin communication. See you soon. Hi and welcome to the section 5 of JSF Fundamentals course named Managed Bin Communication. In this section, we will cover several aspects that involves JSF and CDI managed bins communication. We start with the injection mechanism, which is the most common approach used to provide interaction between bins. Further, we will talk about communication between bins by referencing them directly in the maps where they are stored, such as session and application map. Finally, we will see how to access managed bins programmatically using different features of the JSF API. Now we move on to the first video of this section that deals with injecting a managed bin into another managed bin. In this video, we are going to take a look at the main techniques used to take advantage of dependency injection in JSF. After we will discuss about the old-school JSF default support for injecting JSF beans, we will continue with the CDI beans injection, which is much powerful and recommended to be used. And we will finish with a dissertation about injecting JSF beans into CDI beans and vice versa. Okay, so by a JSF bean, we understand a bean that is managed by JSF, and it is annotated with the well-known managed bean annotation. A JSF managed bean can be injected into another JSF managed bean by using the managed property annotation. In order to exploit the injected bean by accessing its properties and methods, we need to ensure that the injected instance is not null. For this, we have to keep in mind that the injected instance will not be available in the constructor of the injection target, and the earliest place where we can use this instance is in the optional postConstruct method of the injection target. Further, as a general rule in JSF, we don't use objects that have shorter lifespan than the objects we are calling it from. Otherwise, we will get an exception. Another important aspect consists in the fact that starting with the JSF 2.3, the JSF managed beans will be considered deprecated. So, we have to pay attention on aspects such as migrating JSF 2.2 applications on 2.3 and further releases. So, a JSF managed bean can be injected into another JSF managed bean by using the managed property annotation. For example, let's suppose that we have a managed bean named fooBean. Now let's suppose that we want to have access to these bean properties from another bean named buzzbean. For this, we can use the managed property annotation as shown in the following highlighted code. Notice the fact that the injected bean is indicated via its name, obtained from taking the unqualified class name part of the fully qualified class name and converting the first character to lowercase. In addition, the injection is successfully accomplished if we provide in buzzbean a setter method for the fooBean. We can easily associate another name to the bean to be injected via the name element of the managed bean annotation. In such cases, in the target of injection, we point to the bean to be injected via the managed property annotation with the value element. Here, we specify the explicit name as you can see in the highlighted code. For those who are not familiar with postConstruct annotation, let's say that this annotation is used on a method that needs to be executed after the dependency injection is done to perform any initialization. This rule is sometimes omitted by novices who need to perform initialization stuff based on the injected bean. The wrong approach will consist in placing the initialization stuff in the bean constructor, instead of using a separate method annotated with postConstruct as in the highlighted code. This is the earliest place where an injected dependency is available, while in the constructor we will obtain a null value. As we said in the introduction, a general rule in JSF instructs us to not attempt to use objects that have shorter lifespan than the objects we are calling it from. In other words, we have to use objects whose lifespan is the same as or longer than the object being injected into. Breaking this rule will end up in a JSF exception. For example, the request scoped fooBean can be injected in the request scoped buzzbean, but it cannot be injected in the session scoped buzzbean. Or the session scoped fooBean can be injected in the request scoped buzzbean, but it cannot be injected in the application scoped buzzbean. Now let's focus on CDI managed beans and injection aspects. So by a CDI bin, we understand a bin that is managed by the CDI container and it is annotated with the well-known named annotation. A CDI managed bin can be injected into another CDI managed bin by using the inject annotation. Exactly as in JSF, the injected CDI bins are not available in the constructor of the injection target, and they are available in the optional postConstruct method. Further, let's point out the fact that in CDI we can inject objects that have shorter lifespan than the objects we are calling it from. This will not cause an exception. Finally, let's point out again the fact that starting with JSF 2.3, the CDI managed bins are strongly recommended, while the JSF managed bins will be deprecated. Now let's use the inject annotation in a few examples. Let's suppose that we have a CDI managed bin named foo_bin and that we want to have access to these bin properties from another bin named buzzbin. For this, we can use the inject annotation as shown in the following highlighted code. Notice that, exactly as in the case of JSF bins, the injected bin is indicated via its name, obtained from taking the unqualified class name part of the fully qualified class name and converting the first character to lowercase. Now, even if we specify an explicit name for the bin to be injected, the code of the injection point remains the same. Nevertheless, the explicit name should be used to refer this bin from expression language. Talking about the availability of the injected bins, we can say that this is happening exactly as in case of the JSF managed bins. So, there is no need to insist here, and we can proceed further and discuss about the lifespan of the injected bins. As we said earlier, when we are working with CDI managed bins, we can inject objects that have shorter lifespan than the objects we are calling it from. This will not cause an exception, and it is possible thanks to the fact that CDI uses proxy objects, which are capable to re-establish the connection to a live instance. Sometimes you may want to consider CDI and JSF bins in the same application. In such cases, you have to know that we can inject CDI bins in JSF bins via the managed property annotation. In this example, we are injecting the CDI foo_bin in the JSF buzz bin using the default name. When we explicitly set the name of the CDI bin, we need to specify that name for the value element of the managed property annotation. So, if we try to resume our discussion about JSF and CDI bins injection in just a few rules, then we can say that we can inject CDI bins in other CDI bins. We can inject CDI bins in JSF bins. We can inject JSF bins in other JSF bins as long as the scope of the injected bin is broader. We cannot inject JSF bins in CDI bins. In this video, we have discussed about JSF and CDI bins from the perspective of dependency injection. We learned how to inject JSF bins in JSF bins, CDI bins in CDI bins, and how to combine them via injection. Finally, we have set 4 golden rules that we have to know in order to successfully use dependency injection in JSF. In the next video, we will discuss about communication between managed bins using the application and session maps. See you then. Hi and welcome to the second video of section 5. In the previous video, we look at dependency injection from JSF and CDI perspectives. Further, we will discuss about communication between managed bins using the application and session maps. In this video, we are going to take a look at another approach that can be used to share data between beans. Communication between managed beans can be accomplished via an application map or a session map, depending on what kind of communication is needed, across multiple browser sessions or across a single browser session. We will exemplify the idea on the application map, since it is very easy to understand how to accomplish the same thing via the session map. Basically, we want to add a value in the application map from one bean and get the value from another bean. So let's get started. The advantage of using the application or session map is in the fact that multiple beans can communicate with each other independently of their scopes and types. So first, we need to define a helper class that provides two static methods, one for adding a value into the application map and one for getting a value from the application map. In order to add a value into the application map, we simply call the getApplicationMap and use the put method to add the desired value under a key that we will use later to access this value. Further, based on the same getApplicationMap, we can obtain a value by key via the get method. Now that our helper class is complete, we can test it. So, let's take a look to a sample application. First, let's see the code of the application map helper class. Further, we can improvise a simple scenario. In a request scoped managed bean, we put some values into the application map. And in a session scoped managed bean, we simply get those values. As you can see here, the player set action and player get action methods can be easily invoked via two buttons from a JSF page. Okay, let's run the code. Now, if we press the button for getting the value from the application map, we will obtain a null value, because our value is not there. So let's add our value by pressing this button. And now let's get it. As you can see, this time everything worked as expected. In this video, we have covered another approach that can be used to share data between JSF beans independently of their scopes and types. You just saw how to take advantage of the application map by simply writing a helper class for adding and getting values. In the next video, which is the last video of this section, we will cover several techniques for programmatically accessing managed beans. See you soon. See you soon. Hi and welcome to the third video of section 5. In the previous video, we look at communication between managed beans using the application and session maps. Now in the last video of this section, we will cover several techniques for programmatically accessing managed beans. In this video, we are going to take a look at how to programmatically access a managed bean via the evaluate expression get method. In addition, we will discuss about writing a helper method based on the create value expression method, and finally about using the EL resolver of the current EL context. So let's suppose that we have a session scoped managed bean named players bean and a request scoped managed bean named profile bean, and we want to programmatically access players bean from profile bean. For this, we can use the evaluate expression get method defined in the application class. All we need to do is to pass the current faces context and the arguments expression and expected type to the evaluate expression get method. Behind the scene, this method will use the information to call the expression factory create value expression method, which is capable to parse an expression into a value expression for later evaluation. So, since the evaluateExpressionGet method uses behind the scene the ExpressionFactory method, then another approach consists in using directly the createValueExpression method. For this, we explicitly call the getExpressionFactory and pass the arguments to the createValueExpression method. In order to simplify this, we can use a simple helper method and pass to it only the expression and the class. In the last approach discussed in this video, we are using the EL resolver obtained from the current EL context. Once we have the current EL resolver, we can simply call the getValue method, which attempts to resolve the given property object on the given base object. We can easily pass the base as null and our player's bin as property. Now let's take a look over a sample application that contains these three approaches. So in the request scoped profile bin, we can see the piece of code specific to each approach of accessing the session scoped player's bin. We have the first approach based on evaluateExpressionGet method, second approach based on createValueExpression method, and finally the third approach based on EL resolver. The player's bin is simple. The only important thing here is represented by the player name surname action method. In order to test the application, we will call this method from profile bin. So after we initialize the session bin, we can try to access it from the request scoped bin using our three approaches. Let's run the code. First, we can provide the name and the surname. And now we press the button and take a look to the server log. Notice that each approach worked as expected. So this was the last video of this section. And here we have covered three different approaches in a programmatical fashion. Actually, we can say that this section was entirely dedicated to communication between managed bins via programmatical approaches. We have started this section by discussing about dependency injection from JSF and CDI perspectives, continued with communication aspects between managed bins using the application and session maps, and finished with accessing managed bins programmatically via the evaluateExpressionGet and createValueExpression methods and EL resolver. We have now finished the JSF Fundamentals course and we successfully covered the proposed topics. In the first part of this course, we have discussed about dynamic access to JSF application data via expression language. After we've covered the EL syntax, EL resolvers, and value and method expressions, we had an overview of the EL 3.0 new operators, lambda expressions, and collection objects. In the second part of our course, we have focused on JSF communication aspects. Here, we have started with a comprehensive section about passing and getting parameters, such as context, request, flash, and view parameters. Further, we have covered actions, cookies, and hidden fields, and we have finished with aspects of managed bins communication. In order to get deeper in the topics covered in this course, you may like to read my book, Mastering JavaServer Faces 2.2, published at Pact Publishing. In addition, if you are interested in online content, then I recommend you to try the bunch of blogs listed here, and the Stack Overflow page dedicated to JSF questions. So I hope you really enjoyed this course and you have seriously increased your JSF skills. Bye bye.